It's true. But then there were those years. I mean, there was one year you guys were really good. It was the year where Spurrier, Spurrier was such an asshole. He was at his pregame press conference against Kentucky one year, and somebody asked him, what about the Kentucky team scares you? Well, he looks right at this reporter and he says, "Well, here they have one hell of a puncher." And they beat the shit out of us. They had, I want to say it was the year they had that guy that, he's like a great quarterback, but I think he wound up getting kicked out of school. Yeah. He was great, but just couldn't behave.
Steve Garcia and Marcus Lattimore.
Yep.
Yeah, man. College was so much fun.
It was, man. I mean, Tim Tebow in Florida, and Alabama was always Alabama.
Yeah, I'm taking classes at ACC right now.
Oh, nice.
Taking calculus and math is hard.
It is hard. I will say, using programming to help learn some of the more abstract mathematical concepts. I had never really learned what a block really was in school. I remember I remember it coming up a couple times here and there, but never. I did not know what the fuck block was. But in the context of a programming language, so many of those math concepts made so much more sense. I don't know. There was just something about reading a piece of code that was like, okay, because if you understand how to read a piece of code, right? And it's like, here's an algorithm if you want to, you're trying to implement the formula for a particular thing, like a block. It just made so much more sense. I don't know. More people. I wish I was aware of those tools back then. Yeah, I agree. That sucks. It's hard.
I was never good at math, and then I started programming, and now math is a little bit easier, but it's still most of the older programmers I know are super good at math, and then started programming, and it was it's a smooth transition. Just going through and trying to remember everything that I forgot. I never really knew at first. It's fun. I mean, it's fun. It's better than staring at a computer screen for 48 hours a day. After that, turning pages. They have chalkboards there. The teachers write on the chalk. Taking that and Intern Unix.
Oh, dude, that sounds awesome.
I've been messing with Linux a little bit.
Yeah?
That's pretty fun.
I bet. Dude, I bet.
Nobody noticed that we traveled in time, right?
That, or...
I've been messing with Nginx, and I've been messing with
dude, that's great shit. I have not done much of that. I don't think I've done anything.
I mean, I'm going to do a tutorial right now on DigitalOcean. That's a bunch of good stuff. You can kind of go through and get an idea, but I mean, it still takes a few weeks, if not a month, before you really settle in what you're doing. You know what I mean?
Oh yeah. I have to, I'm a big believer in repetition. I'll do something once, and then I'll put it away for a month, and then I'll do it again. Unless it's something that's really closely related to something I already know pretty well, yeah, it typically takes me a couple of different things to really internalize it.
Dude, Linux is it's somewhat simple, the packages they have will blow and came out of the water. It's been written for 20, 30 years. So.
Oh yeah. There's this dude, I just bought a bunch of his ebooks. No.
Hello. Okay. So pizza in the back. Please grab some. There's plenty for everybody. We are missing our speaker right now. So we do have a video in the beginning to intro some of the stuff he was talking about. So we'll play that, and hopefully between now and then, good job. So everybody please pray to the traffic gods to let him through. Alrighty. If you're here for Austin on Rails, you're in the right spot. If you're here for the pizza, welcome still. If you're here for any of the other meetups, please see the front desk. Alright. Who's here for the first time? Nice. Good. We'll do a quick intro in a little bit, but welcome. A few quick links. We have a website called AustinOnRails.org, but most of this stuff is now on meetup.org or meetup.com. So most likely we're gonna post all of this stuff on Meetup. But there is some info there for how to contact us or any of the other stuff. If you'd like to sponsor, we got a page for it there that tells you what you can get out of that. So take a look at that if you haven't seen it already. We are on Slack. If you want to take a quick picture of this, or just remember, AustinOnRails.slack.com is the actual workspace, or aor-slack-invitebot.herokuapp.com if you want to get an invite. Or you can just tweet at me or tweet at Austin on Rails and we'll invite you. And speaking of Twitter, Austin on Rails is the Twitter handle. We do have a code of conduct. It is linked on our website, austinonrails.org/rule_of_conduct. So please know that this is a welcome space for everybody. So if there's anything, any concern, please come to me and we'll resolve it. Parking. Street parking is free after 6, Monday to Tuesday, downtown. There's no longer validation for the Omni parking provided by Captain Packer. So that unfortunately is no longer a thing. Our agenda. What you were doing earlier, mingling and eating, good job. You all passed that one. If you weren't mingling, there will be another chance to do that in a little bit, so be prepared to talk to people. This is a space for you to mingle and network. We will hopefully have a talk with Gal about HTTP to hints with Rails. And then we'll do our normal socialization practice, but here we won't go to a bar or anything. We'll just continue doing it here since everybody's already here. No reason for us to try to drag everybody else around to someplace else. But if you'd like to grab a couple beers with somebody, I'll let you self-organize all of that. Alrighty. Any questions so far about all this? No. Thank you to our sponsor, Capital Factory, for the space, and Shopify devs for sponsoring the pizza. So give them a round of applause. This is the second month that actually third month this year that Shopify has sponsored pizza. The cops. Alrighty, a couple of announcements. Keep Ruby Weird is happening on November 9th. There's going to be a huge discount from $55,555 to now just $105.55. So grab your tickets while they last. Who's going? Who's got their tickets already? Cool. See you all there. RubyConf is happening in Los Angeles on November 13th to 15th. Anybody else got any announcements? Local events? Anything they're doing? Yeah.
Just general anything?
Sure. Related to Ruby and Ruby on Rails, I have to qualify it, I guess.
Okay, come back.
Okay. Let's do a quick intro. Just name and maybe company you're working for, and if you're hiring or you're looking. So my name is Yusuf. I work for Bear & Giraffe, which is my company, a consulting company here in town. I do software consulting. Okay. We got our speaker. Hey, gal. So I do fractional CTO work and web development for startups in town. I am not looking to hire right now, but I am looking for projects. And if I do have more projects, I would be hiring. So that's me. Thanks.
Hi. Corey, do freelance full stack development, mostly in service of marketing, but that's that.
Hi, I'm Sahil. I'm newish to Austin and will probably be looking in a few months.
My name is Scott. I'm a Rails developer, and I'm not hiring.
My name is Brian. I do freelance, mainly in JavaScript, and I'm looking for freelance projects in terms of React.
That's a good job at Rails meetup.
Actually, I
You
don't
know
know
the
if
Rails
I'm at the
React-
right
Rails
meetup.
React
Is this a
for
game
mine.
dev one?
Nope.
Oh, yeah.
No?
That's probably a
All right. Well, I'm Cece. I just got a job, so.
You can still grab pizza if you want. Thanks. I'm Ryan. I'm a software consultant. I'm not looking to hire for work, just here to learn.
Alrighty.
I'm Sarah Brumfield. I have a company that does crowdsourced manuscript transcription as a platform. It's written in Rails. It's for digital humanities, museums, libraries.
Is that Writer Duet?
Say again?
Is that Writer Duet?
Is that what?
Writer Duet?
No.
Nope. It's called From the Page. We may be looking for a brand new intern paid in the next 3 months or so. So if you know anyone who's kind of looking for their first job, we might have a role for them.
Hey everyone, my name is Jesse. I have a full-time job doing Rails, but I'm working on that side hustle, doing servers.
And we're hiring a bunch of people, but you gotta live all over the world to know Scala and PHP as well as Rails. So, you know, you can go to our site, look at the drop downs, figure out where you wanna go. Sydney? Yeah, do it.
Sounds lovely.
But that's pretty much our situation.
I'm Erica. I also work at BigCommerce with this one right there.
Alright.
Hi, I'm Jessie. I'm here to support this guy when he talks and do a slow clap from the back.
I'll talk about myself.
Okay.
My name is Angelina. I work for Logix Lawyers, and we are hiring, so feel free to come talk to me or Justin later.
I'm Justin Mills. I work for Power School. We're not hiring right now, but I think we will be in a month or so.
Hey, I'm Mike. I'm a Rails developer. I work at a small startup. We're not hiring, but hopefully I'll learn some good stuff tonight.
Rebecca. I'm here hanging with him, learning better about what he does.
All right, him.
Hi, I'm Sean, full stack developer for Summit Sports, e-commerce, outdoorsy websites. Interviewing around right now, but overwhelmed, so don't annoy me.
Hi, I'm Justin. I run a development shop, Rails development shop, here in town, and I'm hiring. We do cool stuff like RNA, DNA sequencing. It's called Silicon Development.
Hi, my name's Steven. I work at Baxter Planning as a Rail developer and a little bit of Java. We are looking to hire some Java folks if you really want to spend all your life working on legacy code bases that are giant. Anyway, don't come see me if you're not interested. Do feel me. That's it.
I'm Chris. I do consulting, Rails, Ember, and a little React. So that's me.
I'm Alex. I'm a React Native freelance developer.
My name's Tom. I'm a Rails developer at a company called Versado. I don't think they're hiring, but they may be. Not sure.
Cool. All right. So everybody who's looking, you make sure you took notes of everybody who's hiring, and vice versa. And so we'll have a break after We'll start with a short video about HTTP2, and so everybody who doesn't know what that is can get a little bit of a small primer about that, and then we'll get into the talk. So in between, we'll have a little bit short 10-minute break, and then we can network there, and then after all of that, we can also go back to that as well. You had an announcement, so maybe we can just open it up for a quick announcement if anybody has anything.
I'm in the process of documenting all the street art around town, building a mobile app around that so that people can just find the art here in town, because really Austin is just covered in murals. So if you guys are interested, the app is in the App Store. It's called Big Art. Go look it up if you like art.
Cool. Any other quick announcement before we start? Alrighty.
My name is Ragnar Long. It's actually an old Viking name, so it's pronounced differently than that, but I won't go into that. I come from Load Impact, and I'm going to talk about HTTP2 and HTTP1. So this is a session about protocols. So first of all, who are we? We are basically a load testing service. We generate traffic, simulating users or applications that access a site, application, or API, and we see how much traffic that application can handle before it becomes slow and inaccessible. And we've been going on for quite a while, and we're a fairly popular service. And everyone always says they're hiring, so I tried not to be too cliche, so I wrote we're application positive. We like to receive applications from people who want to work with us. So I'm going to talk a little bit about the protocols, and then I'm going to present some results from a small study we made to try to figure out what exactly the performance gains can be from going from HTTP1 to HTTP2. And usually when I say HTTP1, I mean HTTP1.1, because that's the protocol we're using now. But it's too much of a pain to say 0.1 all the time. So what's the problem with HTTP? Mike Belch at Google did some research a while ago, and he found out that if you have a 5 megabit connection, or if you have 5 megabits of bandwidth between the client and the server, the average web page will load in about 1.5 seconds. That's the page load time in this diagram. And if you double the available bandwidth, load time will only be slightly improved. So what we see is that today people have fast enough internet connections, and the network is fast enough bandwidth-wise that more bandwidth doesn't really help. It doesn't improve load time. So on the other hand, network delay is a big problem to HTTP today. And network delay has a linear relationship with page load time. So if you reduce network delay, you always get faster page load times. So basically, HTTP is a protocol that is very network delay sensitive. And if we go back in history a little bit, the first HTTP specification was released in 1996. And back then, web pages were very small, and internet bandwidth was very, very limited. People were on dial-up modems that could do maybe 40, 50 kilobits per second. And of course, today they have multi-megabit connections, so maybe it's a factor 100 faster today in terms of bandwidth. And this is an invented page load that happened. It's supposed to show a page load in 1996. So we had pages that were very small and consisted of very few resources, an HTML document and some images. And the page loads could look something like this. I've actually enlarged my mouse pointer here so I can point at stuff. It's a huge one. So basically, a client would load the index.html file, like normally happens, and the blue part here is the connection time. So that's the time it takes to set up a TCP connection, which involves bouncing on a few packets back and forth. Not much data is transferred, but the network delay determines how long that takes, that connection setup. And then we have the orange part, which is the request time, basically. The client sends the HTTP request, the GET request, and it takes a while for that packet to arrive at the server, and then the server starts responding and data starts coming back. And then the green part is the download time. So that's the time it takes to download all the data, and that's limited by the available bandwidth. So what we see here is that, well, first the client loads the index.html, then it closes that connection. It opens 2 more connections and downloads 2 images in parallel. And then it closes those connections and opens 2 more, and finally downloads the last images it needs to render the page. And what we see is that the whole page load time is dominated by the download time here. So, and that's because in 1996 bandwidth was so limited that every single piece of data you wanted to download took a long time to download, basically. And the reason it only downloads 2 things at once is that the HTTP RFC said that you should only use max 2 connections per host name to be a well-behaved netizen. What happened since then was that pages grew more complicated and heavier. This is just a graph of what's happened the last 4 years, but this has been a continuous development since the late 90s. So pages have grown really fast in size and also in terms of complexity. The number of objects has gone up. And if we did a page load today using a browser from 1996, we would see something like this. So the browser can only use 2 connections in parallel because it's an old browser. And what we will see is that the download speed, the download time, the green part, is very, very short here. And it's actually been exaggerated in this graph. It's so short today, usually, that it doesn't even register. You can't even see it. So bandwidth has improved tremendously, and that means that download time is almost insignificant. So the majority of time is spent setting up connections and making requests. And of course, that takes time because the network delay is there. If you want to send a data packet to the other side of the globe, it will take a couple of 100 milliseconds for it to go there and come back. And that's the speed of light. It's hard to get around. So here we have a page load with 25 resources. So it's only a quarter of the actual average size of a page today, which is about 100 resources. But we can see that, yeah, there's a lot of iteration. There's a lot of request response, because it can only download 2 things at once. And it tears down the connections and starts up new connections all the time. So then in 1997, HTTP 1.1 was specified the first time. It's been updated since, but that was the first specification. And that's the protocol we're still using today, basically, now, almost 20 years later. And it had some performance improvements. One of them was connection reuse. So if we take the same page load and we add connection reuse, we get a page load time that is reduced because there are only 2 connections being made, and then they are reused. And more requests are sent over the same connections. They're not torn down and restarted. So previously we had a page load time of like 3.8 seconds, and with connection reuse we're down to like 2.8, 2.7. So that's a big improvement. And remember, these examples are just, they're just to show the concept. So these are not real page loads. But then the browser makers realized that 2 connections kind of sucks. It's if we add more connections, it should be faster. So they ignored the RFC and they added more connections. I don't know who started it, but they added 3 or 4. And then all the other browsers had to follow, because if you were the slowest browser around, no one would use you, of course. So yeah, this is what happens when you go from 2 to 4 connections. So you can see the HTML file is loaded with 1 connection, and then the client starts up 3 more connections, and it uses a total of 4 connections to download the rest of the content. And now we're down to 1.5 seconds from 2.7 or something. So it's almost a 50% improvement by doubling the number of connections. And today most browsers use 6 connections per unique host that they talk to. And then we have pipelining, which was also part of the HTTP 1.1 standard. And pipelining was basically the client being able to ask the server for many items in one go. So here we see pipelining in the sense the client begins by retrieving the HTML file, like usual. It opens 3 more connections, and by this, when it's retrieved and parsed the HTML file, it knows it needs 24 more resources to render the page. So it opens 3 more connections for a total of 4, and then it issues 6 GET requests on each of those 4 connections at the same time. And the server can then just push the data out to the client. On each connection, the 6 items will come in sequence, one after the other. So now we're down to like 1 second from 1.5 seconds. So that's also a big improvement. The problem with pipelining was that it never really worked. It was hard to implement. It had interoperability issues. There was a head of line blocking problem that was hard to get around. So in the end, it turned out to be really tricky to get it to work and to get it to actually deliver speed improvements. So the result is that very few applications implemented pipelining, and of those that did, no one today has it enabled by default. No browsers or servers that I know. So pipelining is more or less dead. So people try to get more performance out of HTTP by doing certain optimizations, and basically to get around the weaknesses of the protocol and its delay sensitivity. And the first 3, spriting, inlining, and concatenating, they are there to basically reduce the number of HTTP requests made. So spriting, of course, I expect most people know all this already, so I won't be too long here. Spriting, of course, is to mash together lots of small images into one large image, so you get 1 HTTP request instead of many. And inlining is basically taking images and putting them inside CSS files to reduce also the number of requests. And concatenating is mashing together JavaScript. So all those 3 reduce the number of requests that the client has to make to render a page. And that speeds things up. And sharding is a different thing. Sharding is when you distribute your content over multiple unique hosts to get around the limitation of 6 TCP connections per host. So if you have a client that downloads 100 resources from one single host, it can only download 6 resources at a time because it's only allowed to open 6 TCP connections to that host. But if you spread your content over 3 hosts, you can get up to 18 connections. So that's also a more connections hack to trick the clients into using more connections to download your content. And all these optimizations are, of course, they're associated with a cost. So I think the biggest cost is in terms of complexity. It gets more complicated to develop web applications, and it gets more complicated to operate them. I think that's the biggest problem. But there's also technical costs in terms of overhead. Like if you have many TCP connections, you get unwanted effects like protocol overhead and many connections stealing capacity from other applications that use fewer connections. And also, wow, lost the thread there. Anyway, there's technical overhead, but there's also overhead when you're developing applications. And I think the developing applications overhead, the human time lost, is the biggest issue. So HTTP2 was basically invented to solve these issues and to deliver a protocol that didn't have these flaws. that where people didn't have to do various workarounds to get good performance. And HTTP2 has something called multiplexing, and this is what our invented page load would look like with HTTP2 multiplexing. So what happens here is that the client downloads the index.html file, as usual, and it realizes it needs 24 more resources, and then it asks the server for all those 24 resources at once over one single TCP connection. And the server just sends them all simultaneously over one single connection. And that is multiplexing. And multiplexing is, if we take these two toy trains and see them as two like JPEGs or something that needs to be transferred, then multiplexing means that both images are chopped up into tiny pieces, and those pieces are interleaved and sent over a single TCP channel interleaved, so they are sent simultaneously and they arrive more or less simultaneously on the client side. If we look just an overview at what's different between HTTP2 and HTTP1, HTTP2 is a binary protocol, while HTTP1 is a text protocol, and HTTP2 is also mostly encrypted. The standard doesn't force people to encrypt, but in practice, most clients require encryption for HTTP2. So I think in practice we won't see much unencrypted HTTP2 traffic. The protocol negotiation can happen through an upgrade header, an upgrade HTTP header that the client sends, or it can be negotiated during the TLS handshake using something called ALPM. Multiplexing, that great feature, is done with using something called streams. And streams are basically the different logical channels that can send different data items, and you can have many streams operating concurrently. And the streams are really cool because the client can freely prioritize streams, and the client can cancel a stream at any time at no real cost. So it's very, very flexible and much more efficient than pipelining ever was. And it works. So another performance improvement is header compression. So we see that today lots of headers are being sent with every HTTP request. We have lots of cookie data and stuff that can be quite a large number of bytes for every request. So header compression is included by default in HTTP2, always on. Also, we have server push, which is kind of interesting. It allows the servers basically to push content to the client that the client hasn't asked for, which I don't know if anyone is using yet, and it might turn out to be another pipelining feature that looks good on paper, but it's really hard to actually use in practice, but we will see. I think it's exciting, at least, because it's in theory, it allows you to really speed things up if you can send content before the client knows it needs it. If we look at the status of HTTP2 today, most browsers support HTTP2. All the major ones do. And of the installed base, over 70% today support HTTP2. And server side is also looking very good. All the big servers support HTTP2, and the biggest tech giants also who have their own server applications, they also support HTTP2 today. Firefox collects traffic statistics from all their users, and they've seen that 24% of Firefox traffic today is HTTP2. So that's pretty good for such a short time since it became a de facto standard. So the second part of the presentation is the experiment. Wanted to see what kind of real-world performance gain you get from going from HTTP1 to HTTP2. And what we did was we took a well-known site and we downloaded all the content on the main page, and we hosted everything locally in a lab setup. And then we measured load times using HTTP 1 and 2 and emulating different network characteristics, particularly network delay. So the site we chose was Amazon. And we chose Amazon because it's a well-known site and it's it has a lot of resources, it's a fairly large amount of data, but not so much JavaScript. Dynamic content makes it much harder to host things locally. And the setup was a fairly powerful Mac with VMware Fusion, running a Linux guest operating system. We had Nginx with HTTP2 support, and we had an experimental HTTP2 server called Shimmercat also. And of course, NetDem, the Linux package that allows you to emulate like packet loss and network delay and things like that. And for the client, we used Chrome on the host operating system. And yeah, right into the test results. We saw this is the minimum load time for HTTP 1 and for HTTP 2 as a function of different network delays between client and server. And we can see that HTTP 2 outperforms HTTP 1 by a fairly big margin, and both of them have a linear relationship between the load time and the network delay. So HTTP 2 doesn't behave differently in that way from HTTP 1, it's just better than HTTP 1. We can see that the load time was reduced between 50 and 70%, which is quite good. One thing that I think was a little bit interesting is that the relative speed change, here you can see the speed change between HTTP 1 and 2 in percentage numbers, and the relative speed change flattens out and it doesn't improve relative to HTTP 1 after you get to a certain network latency. And that was a little bit unintuitive for me. I thought it would get better and better with increased latency, but turns out there's a minimum theoretical load time that you can pass really with both protocols. So yeah, between 50 and 70% reduced load time is quite good. Of course, HTTP 2 implementations are still quite young, so they are probably not optimized. They might be a little bit buggy. And the sites, on the other hand, are optimized for HTTP 1.1. And also our lab setup is not 100% realistic. We didn't manage to simulate 100% of the content that's loaded in a regular page load. So it's there are some, you should take this with a grain of salt, but still the difference is quite huge. So I think in most cases people will see quite big performance benefits going from HTTP 1 to 2. And in the worst cases they won't see any performance degradation at least. So we have a test tool, http2.loadimpact.com, that we're currently working on writing a new backend for. So it's not up, it's going to be up next week. And it basically does what we did in our research. So it downloads the content from a site or a URL that you specify, and then it hosts the content locally and loads it locally using HTTP 1 and 2 and simulating some network delay, reasonable network delay number. So you get a figure for how much faster that particular site would be if it was loaded over HTTP 2 instead of HTTP 1. And the code is also on GitHub, so we're trying to make this a completely transparent project. Anyone else can set up the same site if they want to. Yeah, coming next week, so it's not entirely ready. That's it for me, I think. If there's any questions or anything.
Since he can't be here, I will take your questions. Fortunately, that site doesn't exist anymore. At least I couldn't find it. So if you try to use that tool,
well, it's not ready until next week.
Yeah, next week, March 2016. never happened apparently. We skipped over that. So yeah, I'll gladly take any questions that you might have. I'm not an expert like he is, but I've seen this video over and over again, so I know a lot of stuff about it.
Do you have any sense of the current browser landscape? Does everything support it? And updates on the numbers you put up? What percentage of like the Firefox traffic is HTTP2?
Percentage of global traffic, I don't know, but all the browsers support it. I know that for sure.
So it's like a rolling protocol, kind of what they did with ES. So they keep updating the HTTP specs to try to keep it backward compatible, but they're adding features all the time. So saying something like everybody supports it, it depends like what feature set.
That's just like everything else where you're trying to see if any browser supports a specific thing of HTTP 1, 2. I think there are certain browsers support some things, but not others. So yeah, those are the little things that you want to keep up on, like, you know, the different specific ones, like what's it called, the streams and all that kind of stuff. Might be different from one browser to the other.
Well, and it's a race on both sides, right? On the client and the server.
Yeah.
Right? You have to have the server implementing.
I think that's the hard part, right?
Yeah,
that's the
what
part.
kind of-
Anything else?
Other than it just being, I guess, quicker on first page load, is it, so it's faster than HTTP1 essentially? And that's the main benefit, or is there going to be like a requirement by web standards so that, you know, every website has to be HTTP2?
So it will keep being backwards compatible, but the benefit for it that you're going to gain for you and your users are going to see a much better improvement. If you consider the example of Facebook, for example, and the number of assets that you download once you load one single, like your timeline on Facebook, unless they change it, I haven't missed Facebook in a few months. There's a lot of stuff that's happening there. There's a lot of images that are being downloaded. There's a lot of different parts of Facebook that are being downloaded, all that kind of stuff. So instead of seeing things where you got like a fake sidebar that's waiting until everything else finishes downloading, all that stuff, all of that will be now more immediate because of streams and because of the browser now knows ahead of time what they need to go and fetch by just downloading the first initial template with the header that says I need all of these CSS files and JavaScript files and all that kind of stuff. So it won't have to do like this ping pong thing between the server and back, like, hey, what do I need now? What do I need now? What do I need now? So all of that would be sped up and it would be much faster. Because opening connections take time, right? Opening connection, there's a handshake that you make with the server. You say, hey, are you the server that I'm looking for? Yes. Are you connected? Yes. Are you encrypted? Yes. That kind of stuff. Now give me the data. So when you take that all out, which is what he highlighted initially in, let's see. So you see that blue part here. When you get rid of that blue part, it just makes things a lot faster. So there's a benefit there because you don't need to make that handshake multiple times.
What's the blue part again?
So I know it's hard to see from, I can't zoom YouTube unfortunately. The bar here has a blue part, an orange part, and a green part. Okay. The blue part at the beginning is the connection time to the server. It says, hey Facebook, are you, the browser is saying, hey Facebook, are you at this IP address? Facebook says, yes, I am. Are you encrypted? Are you working with an SSL connection? Yes, etc. What do you want? Give me all of these files, etc. Back and forth. So if you reduce that time, you take that out, that speeds up your load.
Would you consider HTTP2 production ready for high secure environments or highly security requirements?
I wouldn't know why not, but I would leave that up to anybody else who might know more.
It's definitely ready. They use it in Google. Like if any of the Google services is using HTTP, so it's good enough for them.
Sorry, I'll come back to you post that. I saw him.
Okay. Yeah, so I was curious if servers can impose a limit on multiplexing, right? So I guess I got a little bit worried for a second, because if you have 100, oh, but it's reusing the connection.
Yeah.
But I was just thinking, if you have 100 different files that are being transferred, is my application in jeopardy of being overwhelmed and running out of memory?
I think he mentioned that a little bit, saying that you can, if I remember correctly in the video, is that there are parts where, yes, many applications can be opening and trying to do more, but your server puts a limit on that. So even if the browser tries to do 100 connection, I think your server has a limit of connection, I believe. Correct me if I'm wrong, anybody else that knows.
Sorry, can you clarify what you mean by the problem of multiplexing? Are you referring to like having it load all these files to stream them at once?
Like a bandwidth limitation.
Yep.
Right. Yeah. Which I mean, it makes sense that you'd have a limit like that on the server, but like at the same time, if you're serving up, if your HTML file is requesting 100 assets, right? Like that bandwidth's going to be used anyway, right? It's just whether it's across one connection or 16.
But also multiplexing never worked.
Yeah, as far as like memory is concerned and stuff, like your operating system is gonna load those files into memory anyway, as I understand, and it'll be put into FS cache, and if that bus FS cache, and hey, you're gonna start going into I/O, and so you'll have a problem anyway. If it's constantly swapping stuff out of FS cache, so 6 of one, half dozen of the other.
That's good.
I mean, if you refresh the page 100 times real quickly, you're pretty much doing the same thing.
Yep.
I was just going to ask, you mentioned how once one browser broke the RFC and supported HTTP2, everyone else felt pressure to do so because they didn't want to be slower. Wouldn't that same dynamic be playing out on the content, like the server side, the companies, because there's like obviously there's like a financial advantage to being faster, generally speaking, or why is that pressure not really coming in right now? Is it just that?
Oh, I think it is.
It is.
Yeah, I mean it is. If your site is slow for any reason, you're probably losing money depending on what business you're in. So it's definitely a big factor for people. That's why you saw all of those hacks, right? That people were doing, like the sharding of the assets servers and all that kind of stuff. Because if images don't show up fast enough, or CSS doesn't show up fast enough in 2018, you're considered really, I guess the bar is much different than it used to be 10 years ago, and so you're considered slow for a lot less than it used to be before. So it is a big sort of push towards like being faster and faster and faster, and then that's where all the ugly hacks come in, and what he called ugly hacks, right? And so there's definitely big incentive to do that. But anyway, who did writing? Yeah, that was fun. I had to learn Photoshop for that, just for that. Cool. I'm gonna take a short break, grab some pizza, and then we'll have our talk coming up. So yeah, go ahead, grab some food, stay empty, don't break your phones.
Have you worked at a couple of factories now?
Yeah, I worked for a company here for about 2.5 years.
Oh, really?
A while back. I'm local.
So they started here and they moved into the big office?
I didn't officially start here. They were a Y Combinator startup that year, I guess it would have been mid-2013. I started like November 2013.
So they moved from San Francisco to SF, or
well, so they were out in SF, but they one of the founders was from here, and The other two were from Minnesota, and they realized what they wanted to do. They wanted to they just had a much larger runway, not being in San Francisco.
I can see that for sure.
So so they set up shop here, and when I joined, it was about there were 12. I think I was 12 or 13, and then when I left, there was about 60.
Yeah, and then
and they moved in their own office. They're over on like 9.
I haven't heard of them before. Yeah, they're like a pretty well-known Austin company.
Yeah, they're really good size systems.